In this video, we're going to look at the Diels-Alder reaction, one of the all-time great reactions in organic chemistry. Let's jump right in. In the Diels-Alder reaction, we start with a diene. That is a conjugated double bond system with a double, single, double. And there are two alkenes or two enes, so we call that a diene. And that reacts with another double bonded compound. And we call this other molecule the lover of the diene or the dienophile. So we'll keep it very basic right now, and we'll look at this diene and dienophile. And the mechanism of this reaction is we have three arrows that go around the horn. So these pi electrons will go make a bond here. These pi electrons go make a bond here. And these pi electrons make a pi bond here. So when we're done, we would make a six-membered ring. This double bond becomes a single bond. We formed this bond. This double became a single. We formed this bond. This double becomes a single. And this single is now a double bond. So we made a cyclohexene final product. That's the basic overview. So as soon as you see a Diels-Alder reaction, always look for this. Get your diene and your dienophile, your three arrows around the horn. They could go either way, and make your final product. And notice this double bond ends up at this location, right in between my two double bonds of the diene. That's where this double bond ends up. So the diene usually is electron rich. We like a whole bunch of electron density in the diene, ready to give away electrons. And the dienophile is usually electron poor. We want it deficient of electrons, so it wants electrons from the diene. So how do we get electron rich? Well, you might have what we call electron donating groups. Groups like an oxygen with a lone pair of electrons that can be donated into the ring. Or you might have an alkyl group. So an alkyl group like a methyl or an ethyl. You can get OR groups. So groups that donate electrons in, electron rich. The dienophile, we like groups that help pull electrons away from the double bond. So one example of that would be like a carbonyl. And that helps pull electrons away from this double bond because we can push the electrons all the way up onto the oxygen. So we like things like carbonyls or maybe nitriles or NO2 groups. They help pull electrons away from the double bond. And of course, these groups help push electrons into the double bond, making it more electron rich. So let's look at the reaction of these two things. Let me redraw them. We have our three arrows around the horn. Zip, zip, zip. And that would make, we form this bond, this double becomes a single, we form this bond, this double becomes a single. Oh, there's a double bond here. My OR group is on this carbon, and my carbonyl is here on this carbon. So that would be our final product for this Diels-Alder reaction. Let's solve a couple of more problems. What if I have this diene and this dienophile? Well, we do our three arrows around the horn. Zip, zip, zip. And that would make, we always make a six-membered ring. So this carbon will be the one with the methyl. This double became a single. This single is now a double. This double is a single. I made a bond here. So this hydrogen's here. This is where the triple bond was. So I started with the triple bond. Now I have a double bond here. And on this carbon is the carbonyl. So you just work your way around the ring. Notice that when you have triple bonds, you end up with a double bond at the end of the reaction. How about this one? Well, I have cyclopentadiene and this dienophile with a nitro on it. I think maybe the best way to do this is to redraw this, but take this point and put it up towards the top. So I'm going to bend that up out of the way. So here's, this carbon is now up here. Now I have my diene all set up, ready to react with my dienophile. I'll do my 3 arrows around the horn, zip, zip, zip. So that would make this 6-membered ring. My double bond is here. This carbon goes up to the point, down to this carbon, and my NO2 would be on this carbon. So that's a perfectly reasonable drawing of it. Other people like to draw these bicycle compounds with the bottom 6-membered ring, more of a envelope, kind of a bent, pocketed kind of version of it. So these are the same thing. Both are perfectly reasonable. That's the basic idea behind the Diels-Alder reaction. Look at this next video and you'll learn more about some of the other details behind the Diels-Alder reaction, but I didn't want this video to be too long. Please subscribe so I can continue to help you with your organic chemistry.